Thank you for the kind introduction. Hello, everyone. I'm excited to be here and share my work with you today. I want to introduce RubyConf, but Matsuda-san introduced shortly. Next RubyConf will be held in my hometown, Ehime, so please join us. Also, today's presentation is almost the same as my talk at RubyConf this year, so I hope you can get a feel for it. Today's main topic is Reline, but before that, let me explain a bit about IRB. Most of you must have used before, right? Thank you. IRB stands for Interactive Ruby, and it is Ruby's default repo. Repo stands for Read Eval Print Loop, which means you can input Ruby code, IRB evaluates it, and outputs the result. You can run it using the IRB command. It is also used as a default repo for the Rails console. For example, when you run IRB, when you run IRB and type is equal RubyConf, the string turns red. When you press enter, the result RubyConf is displayed. If you call a method on S, a completion dialog appears by default. You can move through the suggestions by pressing Tab. The method documentation is also shown. The prompt displays IRB main and the line number. Back to the slide. IRB is something we use often, but do you know how it works? In simple terms, this is how it works. When you run the IRB command, Reline starts up, displaying the prompt, and waits for user input. Once a valid Ruby code segment is entered, it is sent to IRB for evaluation, and the result is displayed on the terminal. IRB runs the code, analyzes it, and applies color formatting. In the image, IRB recognizes RubyConf as a string and colors it accordingly. IRB evaluates the line s equals RubyConf. On the second line, we input s.ascii only. Since s is a string, the suggestions include ASCII only, a string method. The component responsible for showing these suggestions is repo type completer. If repo type completer is not installed, IRB handles the suggestions. The documentation for ASCII only appears on the right and is generated using RDoc. So what does Reline handle? It manages the display and the handling of lines while typing. Reline is responsible for showing the prompt, the cursor after ASCII only, and the dialog boxes. You can think Reline as the front end on the terminal and IRB as a back end. Both IRB and Reline are default gems in Ruby 3.3. I am one of the committers for these projects. My name is Mari Imaizumi. I work at Stores Inc., where I develop Rails applications. My pronouns are she or her. This is my first time in the US and my first time presenting English, so I'm a little nervous. Thank you. Thank you for being here, and please feel free to come and say hi. So let's get back to the main topic, enhancing Reline's features. First, I'll explain what a command line editor like Reline does at its capabilities. Next, I'll compare Reline with GNU Readline, as one of Reline's goals is to maintain compatibility with it. Finally, I'll explain the design and implementation of the undo feature I worked on. I hope to share what Reline aims to achieve and what it can do. So what is Reline? Reline is a command line editor. Here, a command line editor refers to software that runs on terminal emulators and handles user input. Although command line editor isn't a common term, I'm using it here because there isn't a generic term for software like GNU Readline. Examples include GNU Readline and Usability. Reline aims to be compatible with these libraries. When I say a command line editor handles user input, but it might be hard to picture. So let's take a look at what happens without a command line editor. Here are 3 lines of Ruby code. This program displays please enter your name, waits for user input, and prints the entered name when you press enter. Wait a second. So test 1 RB, Ruby, test 1 RB. Okay. Now when we run the program, it waits for input. So let's try entering my name. I mean to type Mari Imaizumi. But I mistakenly typed hard. To fix this typo, I pressed the left arrow key, but instead of moving the cursor, a strange set of characters appeared. This is an ANSI escape sequence representing a cursor back action. I wanted to move the cursor back, but didn't work as expected, and the escape sequence was displayed instead. Let's try using Reline. It's simple to use. Just require Reline and use Reline readline, similar to how Get works. The readline method accepts a single line of input. So back to the terminal. Okay. But test to RB, use Reline. I made my type again. This time, I pressed the left arrow key to move back. Mari, Imaizumi. Yeah. And I was able to successfully change the cursor position and correct the mistake. This is because Reline handles the escape sequence and moves cursor back. Changing the cursor position on a terminal isn't automatic. In this script, Reline processes the escape sequence received from the terminal and adjusts the cursor position. Okay. Thank you. A command line editor provides a set of operations for editing text, like moving the cursor. In tools like IRB or bash, the handling of input keys is done by the command line editor, not by IRB or bash itself. Let me introduce some command line editors. The most widely used one is GNU Readline, which uses in bash, IRB up to Ruby 2.6, and GDB. There's also a library called EditLine, which comes standard with macOS. Reline has been used in IRB starting from Ruby 2.7 and is also used in tools like the debug gem, Highline, and Hexapedia. Now let's look at the features of GNU Readline, a well-known command line editor. The first feature is line editing, which includes basic operations like moving the cursor. Next is history editing, which allows you to navigate through the command line history using the up arrow key. There's also an autocomplete feature, such as pressing the tab key in bash complete a file name. This is provided by Reline. Readline also offers editing commands, such as pressing Ctrl A to move to the beginning of the line and Ctrl E to move to the end. Additionally, it supports macros and various customizations through the inputrc file. Since one Reline is going to be compatible with GNU Readlines, let's do a quick feature comparison. Reline can be most of the basic operations that GNU Readline can, such as line editing, history navigation, and auto-completion. However, it still lacks some advanced features like editing commands and certain configurations that can be set through inputrc, which I will explain later. From the comparison area, Reline may seem like a less capable version of GNU Readline, so let me add that there are some powerful features unique to Reline. First, it can be display dialogues, such as completion dialogues. Second, Reline supports multi-line input, including prompts. While multi-line input is also possible with GNU Readline, Reline's handling with prompts makes it easier to use. Third, Reline is extensible with Ruby. You can customize input line decorations, dialogues, completion suggestions, and termination conditions for multi-line input using RubyConf. Reline aims to be compatible with GNU Readline, but as shown earlier, some features are missing. These include editing commands, key binding for those commands, and toggleable options. Occasionally, users report issues about features available in Readline, but not in Reline, showing that these features would be appreciated. Additionally, Reline is increasingly expected to be compatible with Readline. Starting from Ruby 3.3, Readline X was removed from the default gems, so when Readline X isn't available, require Readline will automatically use Reline. This change solves the issue of installation problems with Readline during Ruby build. However, users may unknowingly switch their dependency from Readline X to Reline, increasing the need for Reline's compatibility features. The issue where require Readline cause Reline can be resolved by installing Readline X. But as a maintainer, I hope users choose Reline over Readline X. Ideally, I want Reline to work seamlessly when users switches from GNU Readline without noticing any difference. I also hope that Reline becomes the preferred choice for users considering switching their command line editor. For example, in Pry, a peer for supporting Reline has been merged into the master branch. So to summarize the challenges so far, Reline aims for compatibility with GNU Readline, so more compatibility is desired. Additionally, it should work seamlessly when required Readline is used. So what specific features are missing? Let's take a closer look at the feature gaps between Reline and GNU Readline. By the way, has anyone here ever written an inputrc file? Please raise your hand if you have. 5? Fewer than expected. Thank you. Inputrc is a configuration file. Both GNU Readline and Reline can read inputrc. It is typically loaded from your home directory or from a location specified by an environment variable. In inputrc, you can set toggleable options, editing commands, key bindings, and choose between Emacs mode or VI mode. Readline and Reline have two editing modes, Emacs mode and VI mode. The default is Emacs mode. VI mode has both command mode and insert mode, but not all VI functions are available. Only simple commands are implemented. To switch to VI mode, you need to add a setting to your inputrc file. Inputrc is a file that can be written using syntax like this. The first line says show mode in prompt on is a setting to display the current editing mode in the prompt. The second line, set vi command mode string, configures the string display the prompt when vi is in command mode. The third line follows a similar pattern. The fourth line is commented out. Anything after sharp is ignored as a comment. Line 6 starts an if statement. You can specify software names or modes in these conditions. For Reline, you can use if Ruby or if Reline. In this case, it configures Ctrl-E to execute Emacs editing mode only when Reline is used. The setting on line 10 applies regardless of conditions. By default, it is set to Emacs mode, so this line adds a key binding that switches to VI mode when Ctrl-S is pressed in Emacs mode. Default key bindings are set within the command line editor. For example, by default, Ctrl-A moves the cursor to the beginning of the line. In VI mode, these are separate key bindings for command mode and insert mode. While customization is possible through inputrc, there are some settings that don't work with Reline. To understand which features are missing, I compared Reline to GNU Readline to see what configuration items are supported. As of April 16, 2024, Reline supports 26% of variables and 44% of editing commands. Some configuration items, like file name completion, are not supported by Reline at all, so overall the coverage is still low. It would be great to implement the features available in Reline, but missing in Reline. However, there are 101 items, including settings and commands, that haven't been implemented yet. We need to start with the most important ones and release them first. To help prioritize, I analyzed inputrc files pushed to GitHub to see how frequently these settings are used. So I looked at the usage to see how frequently each of the 166 configurable items was set. These included items were commented out, so it may not reflect exact usage numbers. Additionally, for functions with default key bindings, actual usage is likely higher than the number of matches found. In total, 6,600 inputrc files were examined. Here are the configuration items with high usage rates. The top item, completion ignore case, is a setting that makes auto-completion case insensitive. It was found in 3,700 out of 6,600 files, which shows it is quite commonly used. Other frequently used settings include history search, settings that make tab completion more convenient, and basic key bindings configurations. On the other hand, some items had a usage rate of 0.1 out of 6,600, indicating they are not used at all. We use information like usage rates, the presence of default key bindings, and issues raised for Reline to decide which features to implement. Recently, we've added features like undo, redo, show if ambiguous, change to editing mode, support for mode conditions in inputrc, and support for bracketed paste mode. Let's take a look at the implementation of the undo feature to understand how Reline operates. From here, we'll dive into Reline's code. First, let's see what Reline does when you input A. Next, we'll look at what happens when Ctrl-A is pressed. Finally, we'll go through implementing the undo command. Let's start by seeing what happens in Reline when we launch this simple script. It's just a script program that requires Reline, calls Reline readline, and prints the result with puts. test 3 RB, this program. When you input A and press enter, A is displayed. From this code, let's examine how Reline works. Simply put, Reline processes input this flow: initialization, waiting for input, handling input keys, and rendering. From here, I show code snippets, some of which are simplified versions or included added explanations. During initialization, Reline sets up various configurable blocks with inputrc for configurations and establishes the default key bindings. After initialization, read IO waits for key input from standard input. From read IO, inner getC is eventually called, and it waits for input using IO wait readable. When input is available, IO get byte retrieves 1 byte at a time. For example, if you input the lowercase letter a, C will hold the number 97. The received input is passed to line editor update. For characters within 7 bits, config editing mode get method is used to match the key to the corresponding method. For example, in max mode, if the key is 97, the default key binding assigns ed insert to A. Then, ed insert is called. It encodes the key, which is a number, into a string and passes it into insert text. The insert text method updates the instance variables that manages the input text. The variables buffer of lines, line index, and byte pointer update. These instance variables play an important role within Reline. Buffer of lines is an array that holds the text being entered. In the case of multi-line input, it contains multiple elements. The prompt itself not included in this array. Line index and byte pointer represent the cursor position. Line index is used to calculate the y-coordinate of the cursor, while byte pointer is used for the x-coordinate. For example, if the input is if 1, 2, 3, and the cursor is after the 3, buffer of lines will contain if 1 and 2, and line index will be 2 with the byte pointer at 7. These values are used for rendering, and A is displayed on the screen. If the end condition is met, rendering is completed and the input waiting loop is exited. If not, it returns waiting for input. Up to this point, we have successfully input and displayed the character A. Next, let's use the same script and input the control A command, which moves the cursor to the beginning of the line. Initialization and waiting for input works the same as before, and when Ctrl A is pressed, the key code 1 is input. Get method is then used to match the key code to its corresponding method. When Ctrl A is pressed, the key code is 1, so ed move to beginning is called. Ed move to beginning sets byte pointer, which represents the x-coordinate of the cursor position to 0, meaning the beginning of the line. After this, the cursor position is recalculated and rendered, allowing the cursor to move the start of the line. The alias method defines beginning of line and vi0, which are commands that can be specified in inputrc. Although the names differ, they perform the same action, so they are grouped using aliases. Now, let's implement undo. Although undo was not among the top used features earlier, it is a common function in most basic editors and it's useful to have. In GNU Readline, pressing Ctrl_ executes undo, so we'll implement it in Reline to work similarly with Ctrl_. So what is undo? Undo is a function that reverts previous actions. However, the way it works varies between editors. In GNU Readline, for example, it likely records continuous keystrokes within a certain time frame as a single unit for undo. This means if you type A, B, C and press undo, the entire A, B, C is erased, reverting to the state before input. In the Reline editor, if you type A, B, C and press undo, it reverts to A, B. Since the behavior in Readline can be somewhat unclear, Reline was implemented with the same approach as Zshell. Here is a simplified overview of undo. When action is performed, it is saved to the history. Conversely, when undo is executed, one entry is popped from the history. It sounds simple. Now, let's implement this in Reline. Current line represents the line currently being edited, and past line is an array that manages history. Let's say A is entered. This is added to the current line, and the previous line is stored as old line. When you want to undo, you need to revert to the state before the current line, so the old line data is pushed to past lines. Next, B is entered. The current line, which had A, now becomes AB. The old line keeps the previous state, which is A. The old line data is then stored in past lines. Now, Ctrl_, which is the key bindings for undo, is pressed. When this happens, we want to revert from AB to A. To do this, one entry is popped from the end of past lines and applied to current line, restoring it. If undo is pressed repeatedly, an empty string is popped, returning to the state before any input. This is how the undo functionality was implemented. The pull request can be found 701 in the repository, so please check it out if you are interested. Let's take a quick look at the flowchart from earlier. When Ctrl_ is pressed, default key binding called undo function. In the undo function, a previous state taken from past line and applied to the current line. The last entry is past line is removed. When rendering is performed, the previous state is displayed, completing the undo operation successfully. Let's look at the demo. When you type if 1, 2, 3 and delete line 2, pressing Ctrl_, undo deletion, restoring line 2. The undo also works correctly in the middle of an input line, and the cursor position returns to where it during the operation. With this, we've successfully implemented undo. Go back to thank you. To summarize, Reline is a pure Ruby gem designed to be compatible with GNU Readline and Usability. It has line editing features and can be extended by Ruby. Note that even when requiring Readline X, Reline may sometimes be called. If you have any feature requests or bug reports, please feel free to reach out on the Ruby Reline repository. Here are the links from the footnotes. These are versions used for testing in this presentation. This concludes my presentation. Enjoy coding on the command line with Reline. Thank you very much.